Hello, my name's James Roper and I'm on the Lagom development team. Today we're going to be looking at an introduction to Lagom, a new microservices framework produced by Lightbend. Today we're going to be looking at three things. First of all, we're going to be looking at what is Lagom. Secondly, we're going to be looking at the Lagom design philosophy. Thirdly, we're going to have a look at the service API and how to actually write services in Lagom. In subsequent screencasts, you'll be able to see the Lagom Persistence API development environment and production experience. Before we go any further, it's probably good to talk about what does Lagom mean. Lagom is a Swedish word meaning just right or sufficient. Often when people talk about microservices, they focus on the micro, saying that the services should be small. We want to emphasize that the important thing when splitting a system into services is to find the right boundaries between services, aligning them with bounded contexts, business capabilities, and isolation requirements. In doing this, a microservice-based system will be able to achieve its scalability and resilience requirements, making it easy to deploy and manage. So the focus should not be on how small the services are, though they will generally be much smaller than a traditional monolith, but rather on having services that are just the right size. They should be Lagom-sized services. Since Lagom is a Swedish word, I wouldn't use my Australian pronunciation as a guide in how to pronounce it. My Swedish colleague, Patrick, has created a screencast on Lagom persistence. I suggest using his pronunciation as a guide. Lagom is a framework for creating microservice-based systems. It can be thought of as having four main features: a service API, a persistence API, a development environment, and a production environment. The service API provides a way of declaring and implementing service interfaces. These interfaces can be consumed by clients and are backed by a service locator for location transparency. The API supports both synchronous request-response service calls as well as asynchronous streaming between services. The Persistence API provides event-sourced persistence entities along with CQRS read-side support. Lagom manages the distribution of persistent entities across a cluster of nodes, allowing sharding and hence horizontal scaling. Cassandra is provided as a database out of the box. The development environment allows running all your services and the supporting Lagom infrastructure with one command, hot reloading your services whenever code changes. No longer do you need to maintain a set of fragile scripts to set up and maintain a development environment. A new developer can get started working on an existing Lagom system with many services in just a few minutes. The production environment is based on Lightbend Conductor and allows simple deployment, monitoring and scaling of Lagom services to a container environment. Lagom has been designed based on a number of guiding principles. Lagom is asynchronous by default. This is not just in its I/O, though of course all of Lagom's APIs use asynchronous I/O, building on Arca streams for asynchronous streaming and the JDK8 completion stage API for futures. But Lagom also makes asynchronous communication the default. When communicating between services, streaming is provided as a first-class concept. Developers are encouraged to use asynchronous messaging via streaming, rather than synchronous request-response communication, as asynchronous messaging leads to higher levels of resilience and scalability. Lagom also favors distributed persistent patterns, in contrast to the traditional centralized relational database. Event sourcing with CQRS is the default way to persist entities in Lagom. Lagom places a large emphasis on productivity. A developer should be focused on solving their business problems, not on wiring services together. Lagom's expressive service interface declarations let developers quickly get the job of defining interfaces done, so they can start implementing them. The development environment is particularly important in developer productivity, both while developing and in the maintenance of it. In a system with many services, developers should not be spending all their time updating their own environment to ensure their services are configured to run correctly. Going into production, developers should be able to just as easily run their services as they do in development. Through using the Conductor sandbox, developers can first test their production configuration locally. Then, with zero friction, they can push their services out to production and manage them through Conductor's interface. The remainder of this screencast is going to be about the Lagom Service API. For screencasts on the Lagom Persistence API, development and production environments, see the Lagom website. Today we're going to have a look at one of the sample Lagom systems, Chirper. Chirper is a social network that allows users to broadcast short messages known as chirps. Before we take a look at the code, let's just have a play with the UI to see what the application does from the user's perspective. Right now I'm on the login page. I'm going to log in as Bob, and now I can see my feed. I can chirp, and we can see the chirps being added to the feed. So far I don't have any friends. To fix that, I'm going to add Alice as a friend. Now back on my feed, I can see both my chirps and Alice's chirps. I can also click on Alice to see just Alice's chirps. Let's now take a look at the Chirper source code. Today we'll just be looking at the friend service. This is the friend service interface. We can see a number of service calls: get user, create user, add friend, and get followers. Each service call returns an object of type service call. A service call is something that can be invoked and implemented and even passed around. Let's take a look into the Lagom source code for the service call. We can see that service call defines three type parameters: an ID, a request, and a response. The ID is an identifier that typically gets extracted out of the path or URL for the call. The request is the incoming message, analogous to the HTTP request body. The response, likewise, is the outgoing message, analogous to the response body. We can see that a service call can be invoked by clients by calling the invoke method. We can also see that since service call is a functional interface, it can be implemented with lambda that matches the signature of the invoke method. Back to our friend service. We can now see that getUserCall takes an ID of string. This will be the username extracted from the URL. There is no request message, but the response message is of type user. Similarly, the createUserCall has no ID extracted, but defines a request message and has no response message. While these methods define the necessary types to use when consuming or implementing the service calls, additional metadata is required to actually map these calls down onto the wire. This metadata is provided by implementing the descriptor method. The descriptor method describes what calls are available, how they are addressed, how the request and response messages are serialized and deserialized, and in fact everything needed to serve and consume the service. For the most part, the defaults provided by Lagom are enough, but everything can be overridden if needed. We can see that the getUser service call is defined to be addressed by the get method at the /API/users/ID path. The ID is a dynamic parameter, and it is what gets extracted into the ID that gets passed to the getUser method. Finally, we can see that this descriptor has auto ACLs on. ACLs are directives to the service gateway, which is a proxy that routes calls from the outside world into the service. With auto ACLs turned on, each service call will be externally accessible at the path it defines. Let's now take a look at how the friend service is implemented. Here we have our friend service implementation. The friend service implementation is a class that gets injected using JSR 330 annotations. The details of the persistence APIs used here we won't cover in this screencast. You can watch Patrick's screencast to see that. Here we have the getUser service call. You can see it's implemented using a lambda. The lambda takes the ID and request message and must return a completion stage. Completion stage is a JDK8 API that provides values that will be available in the future. You may have heard of them in other languages or frameworks under the name promise, deferred, or future. But they should not be confused with the JDK future API, which can only be interacted with synchronously. The first thing that this service call is doing is getting the user from the persistence API. This returns a completion stage of the getUser reply. We then map that using the completion stage then apply method. And if the user was found, we return it. Otherwise, we throw an exception. Our implemented service is then registered with Lagom using a juice module. Lagom provides some helpers to register services. We're using the service juice support interface here, which provides a bind services method that we can pass our service bindings to. This will configure Lagom to serve the friend service interface using the friend service implementation. Now let's look at how the friend service can be consumed from another service. It's important to note that the friend service binds down to straightforward REST calls with JSON bodies, which means you can access it with a service implemented in any language or framework. But for convenience, if you're using Lagom in the consuming service, you can access it using the friend service interface. The activity stream service needs to know what a user's friends are in order to get that user's activity stream, so it's going to need to access the friend service. The first thing it needs to do is bind the friend service client. This is done in a juice module, again using the Lagom service juice support interface to bind the client. Now that the friend service client is bound, it is available for injection into any component. We can see it being injected into the activity stream service implementation here. In the getLiveActivityStream service call, the friend service is invoked to get the user, passing the ID for the user. Lagom will map this service call invocation into a REST request to the friend service. It uses the Lagom service locator to know where that service lives, so you don't need to worry about what the URL for the service is. The service call returns a completion stage of the user, which is then manipulated for further processing. That concludes this screencast. Today we have looked at a brief introduction to Lagom. We have learnt what Lagom is and the design principles used to create it. We have also seen the Lagom Chirper sample app and how one of its services is defined, implemented and consumed. Next, you might like to read the Lagom documentation and check out the Chirper sample app for yourself. Make sure you check out the other screencasts on Lagom, including the Lagom persistence support and the Lagom development environment. Thank you for listening.